All right, let's take a look at homework problem 2 of chapter 4. We're looking at the flow rate Q for the channel that we just solved for above. If it has float finished concrete sides and a 0.5% slope. So from the problem we just did above, we were able to solve for both the area and the hydraulic radius. So it said that the area was equal to 102 square feet and that the hydraulic radius was equal to 3.2 feet. So in order to find this flow rate Q, we're going to go ahead and use that Manning's equation where we put the area in as well. We've used the Manning's equation to solve for velocity, but we can solve for the flow rate by just adding area into that equation. So 1.486 conversion factor divided by the Manning's N times area times the radius to the 2/3, hydraulic radius to the 2/3, and slope to the 1/2. In this case, we're told that it's float finished concrete sides. So you can go back to your textbook and find your Manning's equation chart and see that float finished is going to give you this 0.015 N, but know that the N value will be given to you in any problems on tests or exam. So we'll take this 1.486 divided by this 0.015 times that area we had already solved for, 102. And I'm not going to put any units in here because we have a unit conversion factor and we have units to the 2/3. So I know I have to put my area in square feet, I have to put my hydraulic radius in feet, and my slope in decimal form. So my hydraulic radius is 3.2, and then my slope, I am given that I have a 0.5% slope, but remember for slope it's 0.5%, but when we put it into that Manning's equation we have to put it in as a decimal. So you need to take that 0.5 and divide it by 100, so we do get 0.005. Very important step to remember to do. So 0.005, and of course we have to remember our exponents here, so that 3.2 hydraulic radius is taken to the 2/3 and the slope is taken to the 1/2 power. And we do that math all out into a whole number. I do get 1,552 cubic feet per second. Again, for this Manning's equation for flow, if I put area in square feet, hydraulic radius in feet, slope to a decimal, and my Manning's N as a decimal, I'm going to get out cubic feet per second. Once I know a Q, I can use the old Q equals VA, or in this case I'm solving for V, so I'm going to say V is going to be Q divided by the area. So I'll take that 1552 cubic feet per second, divide it by that 102 square feet of the area that I had already found, and I'll find out that that velocity to one decimal place is 15.2 feet per second.